Now I am going to discuss about searching algorithms. Searching algorithms. First, you should know what is searching. Searching is the process of finding the element from the collections or otherwise from the array. There are two kind of searching process. One is linear search and another one is binary search. The first kind of searching algorithm, linear search algorithm. Second one is a binary search algorithm. Binary search algorithm. Now going to discuss about one by one. The first algorithm is linear search. Linear search algorithm. First you should know what is linear search. Linear search means the searching process finding search every element from the array. For example, the array contains 5 elements. For example, the first element 5, then 8, then 4, then 10, and next element 3. This linear search algorithm going to search each and every element from the array. First, suppose the search element. Now the key element is, for example, 5. First, compare with the first element. Now this first element is, for example, now this is an array ARR of 0th index 5. Then next element index 1, next 4, next 10, and next 3. Now our search key is 3. Now compare with each and every element. Now the first we found the first element in the 0th index. For example, our search key is 5. 5 compare with 5. Now key equal to our search element. For example, AR of 0. Now the element is found. Now the element is found. The element is found at 0 index. Next, for example, second case. Now the key element is, for example, 3. Now the key element is 3. First compare 3 with 5. Not equal. Next 3 compare with 8. Not equal. Next 3 compare with 4, now not equal. Next 3 compare with 10, not equal. Now 3 compare with 3. Now the key element is key equal to array of 4. Now the element is found. The last element is our search element. Now the key element is found in the last position. Now the next case, for example, now key equal to 4. First, I'm going to starting from the first element, 0th index element. Now 4 compare with 5, not equal. Then 4 compare with 8, not equal. Next 4 compare with 4. Now key equal to array of 2. Now the element is found. Now our search element is found. Now the first possibility, our search element is found index 0. Next situation, our search element is found the last index position. Next third situation, our search element is found at mid, for example, third iteration. Okay. Now this time complexity for this search algorithm is time complexity of this linear search algorithm. The best case complexity is big O of 1. Suppose the element found the first index means the time complexity of this best case complexity becomes big O of 1. And the next second worst case means the search element is found is last element. For example, 0th index, index 1, index 2, index 3 and index 4. For example, n equal to 5. big O of n. Therefore, there is a need for n number of iterations. And the next average case means average case. Suppose the element is found this index 2 or otherwise mid index element, or otherwise this element means approximately it takes n number of iteration. Therefore, commonly we can say the linear search, the average case also a big O of n. Commonly we can say the time complexity of linear search big O of n. Okay, big O of n means therefore commonly take n number of iteration. Therefore, it takes more amount of time compared to the next algorithm is binary search algorithm. Binary search algorithm is the faster algorithm compared to the linear search algorithm. This linear search algorithm search compared with each and every element from the collection. Search each and every compared with every element from the array. Okay. Best case means big O of 1. Therefore, there is a need for only one iteration. Worst case means big O of n iteration. Average case means approximately it takes n iteration. Therefore, commonly we can say the time complexity for this linear search algorithm is big O of n. And second, now going to discuss about the second algorithm. This linear search algorithm, suppose for example the collection contains 1000 records. Suppose our key element is found out 999 location means it compared with each and every element from the collection. Therefore, it takes more amount of time. Therefore, the alternate solution is a binary search algorithm. This is the second kind of algorithm. This binary search algorithm, there is a need for input is sorted input. For example, 10, 20, 30, 40, and 50. Now the input should be the sorted input. First, we are going to find out the low value, low equal to 0. High equal to number of elements 0, 1, 2, 3, 4. The last index, the index starting from 0, then 1, 2, 3, 4. The starting index is low and the end index is high. Now the high value is 4. Now first we are going to find out the mid value. Mid equal to low plus high divided by 2. Low plus high divided by 2. This example, the low value is 0 and the high value is 4. 0 plus 4 divided by 2 becomes 2. Now the mid value becomes 2. Okay. Suppose our search key, for example, the search element is, for example, 30. Now array of mid is array of 2. Array of 2 equal to 30. Now key equal to array of 2. Now the element is found. Suppose our search element is found, the mid element means there is a need for only one iteration. The only one iteration is enough. Suppose our search element is, for example, 40. Our search element is 40 means, for example, greater than mid value. For example, our search element is the key value equal to 40. 40 is greater than the mid element 30. Therefore, now only we can perform the search process. Only the right no need to perform the search process, the left half of the array. Okay, now the low value going to be changed, mid plus 1, and already the previous mid value 2 plus 1, 3, and the high value is the previous value. For example, the previous value is 4. Now we are going to discuss about parameter passing methods. Parameter passing methods. There are two types of parameter passing methods. One is the call by value. The first one is call by value, and the second one is call by reference. The first one call by value, second one is call by reference. There are two parameter passing. The first one call by value, second one call by reference. First you should know the example for call by value. First call by value example. For example, swapping of two numbers. For example, first main program. Inside now integer a value equal to 10 and b value becomes 20. Okay. Now this is the function call swap of a comma b. Okay. Now the function is called. Now going to write the definition part. Now the definition part is void return type. The function name is swap of integer x comma integer y. Now next integer term, we can take one variable term. Now there is a need for another one variable term. Now x value equal to y. Next y value equal to term. Now printf of percentage d and then percentage d, then print the x value comma y value. Okay. Now this call by value, first the main program. The main program contains two variables. The first variable is a and the second variable is b. The variable a contains the value 10 and the variable b contains the value 20. Okay. Now the swap is the sum program. Inside the sum program there is three variables. One is term, another one is x, and another one is y. Okay. Now first assign the temp equal to x. Now the low plus high divided by 2. For example, the low value is 0 and the high value becomes 1. Now 0 plus 1 divided by 2. Now the mid value becomes 0. But our search element is 20. Our mid element is now mid of array of 0 is the mid value, array of 0. Now it is greater than mid value. Therefore, now low equal to 1 and high equal to 1. Now mid value becomes 1 plus 1 divided by 2. Now 2 divided by 2, 1. Now the search element ARR of mid equal to key. For example, the search key element is 20. Now the search key is 20. Now ARR of mid. ARR of mid means ARR of mid is 1. Now the element is 20. Now 20 equal to 20. Now the search element is found. search element is found. Now going to discuss the complexity of this binary search algorithm. This binary search algorithm, the complexity of binary search algorithm, time complexity of binary search algorithm, time complexity, big O of 1 is a best case. The best case is big O of 1, and then big O log n for average case and worst case. Average and worst case. Average case and worst case. Why we take this log n means every iteration. First iteration, the number of element is 5 element. Then after that, only the search element is greater than mid element means only we can search half of the right half, or otherwise less than mid value means we can search left half. Therefore, the first initially 5 element. So after the first iteration, number of element divided by 2. Only we need to cover. Only we can search process only 2 element, either right side or left side. Therefore, now going to discuss about the parameter passing methods. There are 2 parameter passing methods. One is call by value and another is call by reference. First we are going to discuss about the call by value example. For example, swap of 2 numbers. For example, integer main of, now this is the main program. Now integer a value becomes 10 and b value becomes 20. Okay. Now a value is 10, b value becomes 20. Now the function call swap of a comma b. Now this is the function call. Now the function definition part, void swap of integer x, integer y. Okay. Now here another one variable. Now declare one variable integer temp. Now temp equal to as in x value. Next x equal to y. Next y equal to temp. Finally print the x value and y value. Now percentage d, ampersand x, x value and then y value. Okay. Now what is call by value? For example, first main program. Inside the main program, there is 2 variables. The first variable a and second variable b. Now the value of a is 10, b value is 20. Okay, next is swap is a subprogram. Now inside the subprogram, the first variable term. Then next variable x and the next variable y. Now what is term equal to x? Whenever the function is called, passing the data. Now this actual data is 10 and 20. Now the 10 is copied with the a value. Now copied with 10, 20. Now 10 is copied with x and 20 is copied with y. Now temp equal to x. What is the x value? 10. 10 as in the variable temp. Next x equal to y. Now x value becomes 20. Then y equal to temp. Now temp value is 10. Okay. Now after swapping, now print the x value and y value. Now the output of x value and y value. Now x value is 20 and y value becomes 10. Now this is the output. Okay. But here this main program now print of percentage d percentage the A value and B value. But the output of this one, A value remains 10 and B value remains 20. Now the changes made only the subprogram. It will not reflect the main program. The main program, A value and B value always remain the same value. A value 10 and B value 20. But only changes made in subprogram. Now X value becomes 20 and Y value becomes 10. Now this call by value changes made in the subprogram. It will not reflect the main program. This is the call by value. Okay, next we are going to discuss about call by reference. Next, second one is the call by reference. Second one is the call by reference. First, main program. Now, this is a main program. Now, declare the function void swap. This is a pointer type, integer, pointer. Now passing the two pointer variables. Now integer A equal to 10, B value becomes 20. Okay. Now the function call swap of ampersand A, ampersand B, ampersand A, ampersand B. Passing the address of this variable. And the next definition part, void swap of integer pointer X, integer pointer Y. Okay, next same as the previous example. Now here also declare one variable. The variable is temp variable. Next pointer X equal to pointer Y. Then pointer Y equal to the variable temp. Okay, now printf of percentage D pointer X, pointer Y. Now the main program. First the main program. Inside the main program there is two variables. One is A and another one is variable is B. Now the variable A contains 10. The variable B contains 20. The value becomes 20. Now this is a subprogram. This is a swap program. Now the swap. Inside the variable temp and one variable X and another one variable Y. Okay, this is Y. This is Y. This is temp. First pointer X now. Passing the address of this variable. The first variable address, for example, 1000. Second variable address, for example, 2000. Inside the function call, passing the two address. The first address is 1000 and second address is, for example, 2000. Okay, first address 1000 and then second address is 2000. Now this pointer X and pointer Y. Now 1000 and passing 2000. Okay. Now the variable X contains 1000 and the variable Y 2000. The variable temp the variable temp. Now pointer X. The variable X contains 1000. Pointer X means refer pointer variable contains the address of another one variable. This pointer X refer the 1000 address inside the data is 10. Now refer the data. Now pointer X equal to temp equal to pointer X. Now temp assign 10. Okay. Now pointer X equal to pointer Y. 2000 address contains the data 20. Okay. now this 20 changed to 10. Now pointer x equal to 10. What is the term variable already contains 10. Now this the variable x the variable x 20, and now 20 changed to 10. Now this is called by reference. Changes made in subprogram. Only we made changes in subprogram, but it will be reflected in the main program. This a value, now a value becomes 20, and then b value becomes 10. Okay, now print off the pointer x and pointer y. Now the pointer value pointer x becomes 20 and the pointer y becomes 10. Now changes made in subprogram. It will reflect the main program. This is called call by reference. Okay, changes made in subprogram. It will reflect the main program. This is called by reference. Okay, this is call by value and call by reference. There are two parameter passing method. One is call by value, one is call by reference. Call by value, changes made in subprogram will not reflect the main program. But call by reference, changes made in subprogram, it will reflect the main program. Okay, these are the two techniques of parameter passing methods. And next, going to discuss about one linear data structure is stack. Stack using principle last in first out, last in first out, last in first out. The last inserted element going to be removed first. This stack is a linear data structure. The data can be arranged in a sequential manner. Mainly we can perform two operations. One is push and another one operation is pop. Push means insert. Pop means deletion, insertion and deletion. Push means insertion, pop means deletion. Okay. These are the two operations mainly performed on stack. For example, initially the stack is empty. Suppose we can perform the insertion and deletion process can be done through the single end. That is called the top of the stack. For example, this is the stack representation. Now this is the stack is empty means now top equal to -1 means now the stack is empty. Now the stack is empty. Now push, for example, push 10, push of 10. Now going to insert this element 10 into this stack. Going to perform the push operation means first going to check whether the stack is overflow or not. Overflow or not. Already full or going to check whether the stack is full or not. If the stack is containing the space means top equal to top plus 1. Top plus 1. Already the top is -1. -1 plus 1 becomes 0. Now this is the top of the stack. Top of the stack, the index 0. Now the element going to be inserted. Okay, now we have inserted only one element. Now the second element is now we are going to insert the element 20. The same process again check the stack is overflow or not. The stack is full or not. If the stack is full means we cannot perform insertion. Otherwise, increase the top equal to top plus 1. Previous top value 0. Now increment the top value by 1. Now the top is 1. Now the already contains the element 10. Now going to insert one new element. The new element is 20. Now the top of the stack is pointing here. Now already inserted two elements. Now again we are going to perform the push operation. Now push of 30. Now going to perform again another one push operation. First we are going to check whether the stack is full or not. Stack is full means we cannot perform insertion. Otherwise we can perform the push operation. Now increment the top value. The previous top value is 1. 1 plus 1 equal to 2. Now we can insert the new element. The first 10. Next 20. Now the last inserted element is here, pointing 2. Now this is the top of the stack. Okay. Now this is a push operation. Suppose we are going to perform the pop operation. Pop means we are going to remove the element from the stack. Already the stack contains 3 elements. Now we are going to perform pop operation. Pop means deletion operation. Suppose going to perform the deletion operation means we should check whether the stack is empty or not. The stack is empty or not. If the stack is empty means we cannot perform deletion. Otherwise, top equal to top minus 1. Now, already the top is pointing the index 0, index 1 and index 2. Now, top equal to top minus 1. Now, top equal to the previous top value 2, 2 minus 1, 1. Now, this element going to be removed. Now, the top is pointing 1, the index 1. Now, again going to perform this pop operation. Now, pop operation means again top equal to top minus 1. The previous top value 1, top equal to top minus 1, 1 minus 1 becomes 0. Now, this next element going to be removed from the stack. Now, top is 0. Now, top is pointing 10. Now, again perform pop operation. Now, top equal to top minus 1. 0 minus 1. Now, this is top equal to minus 1. Now, remove the last element. Now, the stack is empty. Now, top equal to minus 1. Now, the stack is empty. Now, the stack is empty. Okay, the stack can be implemented with array and linked list. Okay, that is